Let's look at a simple compound inequality, and we'll say that 3 is going to be less than or equal to 5 minus x, which itself is going to be less than minus 7. Now when we look at this, we are remembering that we're trying to find critical points that are bounding our domains, and we're going to resolve by testing those domains on the number line. So first we replace the inequality with an equal sign, so I have 3 equals 5 minus x, and I have 5 minus x equals negative 7. Now solving this normally shows that we're going to subtract 5 and find that minus x is minus 2, and then dividing by that negative 1, finding that a critical point exists where x is 2. And on the other side, subtracting 5, we see that negative x minus x is minus 12, and dividing by the negative 1, we see that our other critical point in this compound inequality is x is 12. Now we place those on the number line, and we have 2 and 12. Now note that the 2 started with equal to, so it's going to be a solid, and the 12 is a less than, and we'll represent that it's not included by using an open circle. So now I have my 3 domains, A, B, and C. And that's what I'll call them anyway. And we recognize that domain A is minus infinity to 2, and that's with a bracket, and B is a bracket indicating that's included, 2 to 12. 12 is not included, which we represent with a paren, and of course C is 12 to infinity, and of course all the infinity symbols are with parens, never a bracket. So now I test, and I see that domain A has my favorite value 0, and when I plug my 0 in for x, I see that 3 is less than 5, but 5 is not less than minus 7, so it's not domain A. And then plugging in a value in B, I'm going to choose 5 itself. So choosing 5 for that x, I now have 5 minus 5, which is 0. Well, 3 is not less than 0, so that domain does not work either. And then I choose for domain C, I'm going to take a large number, I'm going to take 1,000. And so I'm going to put 1,000 in here. And it can be readily seen that 5 minus 1,000, that's going to be negative 995. 3 is not going to be less than a negative 995. So domain C does not work either. So for this particular inequality, after testing all the domains, I see that there is no solution.